Right, welcome back. Today we're going to be solving exponential equations. We have solved these before, but we were solving the easy ones, where you could get both sides to be written as a power of the same base. Well, the ones that we're going to be doing today, you're not going to be able to do it that way. Okay, so if you look at example 1 here, it says suppose 6 to the x power is equal to 42. If we try to do it the old way, or rewrite both sides as powers of the same base, you're not going to be able to do that. You can't rewrite 6 and 42 so they have to be a power of the same base. But we could take it wants us to just estimate what the value of x would be. So let's think about some powers of 6. We got 6 to the first is 6, 6 to the second, we got 6 to the first is 6, 6 to the second is 36. What we're looking for is 6 to what power is 42? Well, we got 6 to the third. What is that? Is that 216? Mr. Stuckey? 6 to the third, is that 216?
Yep.
Okay. So that means 6 to the x equals 42 would be in somewhere in between 36 and 216. And 42 is a lot closer to 36. So we could give an estimate. We could say x is about 2.015. I'm just making up some numbers. I don't know what x is. So just estimate the value of x. I think it's going to be close to the number, the exponent of 2. Right, so let's actually solve it. So this is what the new stuff that we're going to be doing today. So I want to solve this. I want to solve 6x is equal to 42. So what we're going to do is we're going to take the log of both sides of this equation. You can do anything to an equation as long as you do it to both sides. So I'm just going to take the log of both sides of this equation. And now what we're going to do is we're going to use those logarithm rules that we learned. Remember, when you have an expression here that's raised to a power, you can move that exponent to the front of your logarithm. So now what we have is x times the log of 6 is equal to the log of 42. And notice I use the log, the common logarithm, because I'm going to want to be able to use my calculator to do this. I didn't use log base 2 or log base 3 or log base 5 because our calculator doesn't do that. So I'm doing base 10 here. So now I'm trying to solve for x. Well, on this side I got x times the log of 6. So what I can do is I can divide both sides by the log of 6. And then if you do that, log of 6 divided by log of 6 will cancel out. So we get x is equal to the log of 42 divided by the log of 6. This is our exact answer. This is the exact answer of value of x. I want to see this. I want you to show me that you can find the exact answer. And now I want you to use your calculator to approximate it. So this is what we've been working on last week. So you just type in log of 42 divided by log of 6. And you should get about 2.0860. And again, we're going to take it out to 4 decimal places. And if you look, I guess 2.015. That's pretty close to 2.0860. All right, so let's try another one. So C asked me to find 7 to the x power is equal to 20. 7 to the x power is equal to 20. On the one above, I took the common log of both sides. Well, you can use also the natural log. So it doesn't matter which one you use. So this time, I'm just going to use the natural log. So I'm going to take the natural log of both sides of this equation. And then I'm just going to do it like I did before. Move the x to the front. So now I got x times the natural log of 7 is equal to the natural log of 20. And then we're going to divide both sides by the natural log of 7. And we get the value of x. X is equal to the natural log of 20 over the natural log of 7. I want to see the work on the homework. I want to see you writing out the exact answer. This is the exact value of x. And then I want you to use your calculator to approximate it. So type in the natural log of 20 divided by the natural log of 7. You get about 1.5395. This is the new stuff that we're doing. This was a really easy ones for the new stuff. But you got this is the process that we're going to be using. You either can take the common log of both sides or the natural log of both sides. You could do other logarithms, but then you're not going to be able to estimate it because your calculator does base 10 and base E. All right, so let's do a couple more examples. These are going to get a little more difficult as we do them. So here's the next one. Solve the given equation, round your answer to 4 decimal places. So we got 2 raised to the x minus 5 power is equal to 12.2. All right, so we're going to start off by taking the log or natural log of both sides. I'm just going to use ln just because it's one letter shorter. We have the natural log of the quantity 2 to the x minus 5 is equal to the natural log of 12.2. So now I can move my exponent to the front of my logarithm. But because my exponent is 2 terms, when I move it to the front, make sure you put it in parentheses. So it's going to be the quantity x minus 5 times the natural log of 2 is equal to the natural log of 12.2. This one I'm actually going to show you 2 different ways you could solve it. I don't really care which method you use. So the first method I'm going to use is I'm just going to get rid of my parentheses over here by using the shredder property. So I'm going to take the natural log of 2 times x. X times the natural log of 2 is x natural log of 2. And then natural log of 2 times negative 5 would be minus 5 natural log of 2 is equal to the natural log of 12.2. We're trying to solve for x. Okay? So this is just like a normal equation except we got logs in it. So we're going to add 5 natural log of 2 to both sides of my equation. These cancel out. We got x times the natural log of 2 is equal to the natural log of 12.2 plus 5 natural log of 2. And then last, we're going to divide both sides by the natural log of 2. Divide both sides by the natural log of 2. And what happens is this cancels out. So this is your answer. But we can clean this up and make it more easier to type into our calculator, just like we did last week. We want to combine the 2 logarithms on top to a single logarithm. So first thing we're going to have to do is take this 5, move it to the exponent on the 2. So we get 2 to the 5th, which is 32, right? So this would be 32 times 12.2. So if I take 12.2 times 32, we get 390.4. And then on the bottom, it's already a single logarithm, so we're just going to leave that alone. So this is your exact answer. And then I just want you to type that into your calculator. Give me the approximation. So you should end up with 8.6088. So like I said, this one I was going to show you another way you could have done it. The first step is still the same. So the first step is still going to be the same. So I'm just going to rewrite the problem. Let's see. What was the problem? 2 to the x minus 5 equals 12.2. All right. So let me show you another way you could have done it. You might like this way better. But this way that I'm getting ready to show you doesn't always work. Okay? But it does work on this one. So you got 2 raised to the x minus 5 is equal to 12.2. Let's do the log this time. The log of both sides. So this would be the quantity x minus 5 times the log of 2 is equal to the log of 12.2. So now what we could do, instead of doing the Schroeder property, I can just go ahead and divide by the log of 2 here. And divide by the log of 2 over here. So these will cancel out. So over here we just got x minus 5 is equal to the log of 12.2 divided by the log of 2. And then last, what we could do to solve for x, add 5 to both sides. And these cancel out, so here's the answer. X is equal to the log of 12.2 divided by the log of 2, whatever that answer is, plus 5. And you can do this on your calculator. What I recommend is you do this first, add equals, and then go plus 5. And you should end up with 8.6088. Right, so one more thing. The last one here. This one's going to be the most difficult one. The reason it's more difficult than the last two is because you have variables on both sides of the equation. But you're going to do the same thing. So you're going to start off by taking the natural log of both sides of the equation or the common log. It doesn't matter which one you use. Again. And then we're going to use our exponent rule to move that to the front of my logarithm. So it's going to be the quantity 2x minus 1 times the natural log of 3 is equal to the quantity 1 minus x times the natural log of 5. Now this one we can't do that second method on because we have x's on both sides. So we can't just divide by the natural log of 30. It's going to get too chaotic if you did do that. So you're going to have to do it the first way I did, doing the distributive property. So this would be 2x times the natural log of 30 minus 1 times the natural log of 30, so it would be just the natural log of 30, is equal to the natural log of 5 times both of these. So 1 times the natural log of 5 would be the natural log of 5, and then minus x times the natural log of 5. Alright, so we're trying to solve for x. So what you want to do on this one is collect all your terms that have x on one side. You notice this term here has an x, and so does this one. So we want to get them on the same side. So I want to move one of them. It doesn't matter which one you move. I just like to keep mine positive if I can. So I'm going to move this one over to the right side. So I'm going to add x natural log of 5 to both sides of this equation. And then I'm also going to do another step. I'm going to get all my x's on one side, and then I'm going to get all of my other stuff on the other side. So that means I'm going to get rid of this one. So I'm going to add the natural log of 3 to both sides. So let's see what we end up with. So now we got 2x times the natural log of 3 plus x times the natural log of 5. These cancel out. Is equal to the natural log of 5 plus the natural log of 3. These cancel out. Trying to solve for x. So we gotta get x by itself. So we're gonna have to use an old trick that we learned a long time ago called factoring out the GCF. Since both of these have x, we can factor out an x. It's like doing the destructive property but backwards. So if we pull out an x from these two terms, we end up with 2 natural log of 3. Let's rewrite that. 2 natural log of 3 plus natural log of 5. And then that's equal to, well, we just leave this as a natural log of 5 plus a natural log of 3. So now, I want to get x by itself. So let's divide both sides by this big long expression here. These cancel out, and we have x by itself. And this is our answer right here. But we can clean it up like we did last week. The top two, we're adding two natural logs together, so they have the same base. So we can write the top as the natural log of 15. And then the bottom, we can do a similar trick. But before we combine them, we gotta get this 2 and move it here. It becomes an exponent. So this really is the natural log of 9 plus the natural log of 5, which would be the natural log of 45. So this is your answer. This is the exact answer of x, and then I would want you to approximate it. And if you do that correctly, you get 0.7114. On this assignment, if you want to get full credit, you got to show all your work, just like we did on the notes. I want to see all of it. I don't want to just see the answer. Okay? Don't skip any steps either. Make sure you're showing all your steps. And people taking a close look at it.